Welcome to the final episode of our Quadric Chimera series, where we covered everything from the architecture to the potential scalability of the GP NPU. That being said, our final part 5, will have comparisons against some other scalable IP and some of my final thoughts on the product line. Thank you very much, and let's begin. In our comparisons for the Quadric Chimera, I decided to pit it against the Expedera Origin and the Siva New Pro M. All three of these product lines claim to be scalable, and they're also delivered as soft IP, which allows for greater flexibility when it comes to integration. And for our three comparison points, we're going to be discussing the architecture, the peak performance as given by TOPS, and yes, I still cringe every time I say TOPS, for as a performance metric, and some of the X factors associated with it. And hopefully through this comparison, we're not going to be able to necessarily say one is definitively better, but we'll be able to do a fair pro-con kind of trade-off shtick with each of these pieces. So as we run through the architecture, we've covered the Quadric Chimera, but as a bit of a summary, it features a unified processor architecture where it combines the NPU, the DSP, and the CPU into a unified pipeline. The Expedera Origin pulls from its networking roots, where it uses something called a packet-based architecture. This allows the data to be quantized and bundled into these packets for more deterministic push and pull of data across the fabric. And the Siva New Pro M is a little bit more of a standard offering comparative to the other two, where it features more of a programmable vector processor outfitted with Mac units, and this allows it to be controlled by either a host CPU or the host IP that it generally is sold with. Now, for the peak tops, and we're going to have a little bit more of a nuanced discussion for this. The Siva claims that its new Pro M can reach up to 2 petaops of theoretical performance using the NPM32K. The Expedera Origin can reach greater than 1 petaop in the Origin E8 line. And the Quadric Chimera can reach a theoretical performance of 864 tops. However, for each of these product offerings, it requires you to take an IP core and scale it or tile it and connect it through a data fabric. The trick when you start to do these pieces is what is the minutia or the fine-grained details or granularity in your data fabric? Are these companies providing the data fabric, or is the data fabric going to be intrinsic within the IP? Now, if the data fabric is intrinsic with the IP, it makes some of these numbers more believable. But if you have to stitch together the data fabric, then you may get into bottleneck issues as you pass data from core to core. And then on top of that, depending on the size of the IP, there may be data locality issues and latency as you pass cores from one side of your IP to the other side of your IP. Now, all of these are well suited for maybe an ADAS system in the L3, L4 range. You could also use them for localized inferencing on a laptop or a smartphone, but they may struggle in the edge server or the data center inferencing applications. Now, for the X factors, and it's kind of what makes each of these products different. Quadric, as we've discussed with the unified processor architecture, also features intermixed instructions. This allows users to write one line of C++ code, and whether it's a better fit for the DSP, the NPU, or the CPU, you'll have the compiler take care of it and intermix the instructions into a single binary. They also claim to have deterministic processing, which is important for high reliability applications such as automotive and mil-aero. And they feature localized memory. So localized memory is a very interesting bit. This allows folks to take the individual weights and the data, store them locally, and then you will have less latency when you're running your models. Now, for the Expedera Origin, their claim to fame is that they have an 80+% utilization rate. Now, when these claims were initially made, it was during the times of ResNet, so a little bit it's been a while since they've updated those numbers. Also, with the packet-based architecture, this allows them to be a little bit more deterministic in their programming, also useful for high reliability applications. And finally, with a single piece of IP, not necessarily taking a tiling approach, it allows users to run multiple models concurrently. Now, this is pretty useful for the application processor-ish market with like smartphones and PCs, because you're going to have a bunch of smaller models running concurrently, and with that, multitasking becomes a lot more useful instead of, let's say, your data center tasks where you may just be running one large model over and over and over again. Now, the Siva New Pro M also touts multitasking, but its I guess X factors or differentiating points are more on the sparsity and compression side, and the advanced quantization that it can do. So the compression allows it to minimize the amount of dead data floating around. So all your non-ops will start to get washed away. And this is also kind of plays into the sparsity and activation side. So this allows unnecessary memory and compute cycles for non-ops. And finally, quantization, for those who don't necessarily know, allows you to take data in a higher precision data format such as FP32, FP16, and convert it to something like int8 or int4, where you're actually using less bits to represent a similar amount of data, making the processing much more energy efficient. It doesn't necessarily scale up and down linearly with the data type, but it definitely drives a lot of power savings. Now, that being said, each of these products are unique and each of them have different trade-offs. I personally do like the idea of the Quadric Chimera and Expedera Origin for more high reliability applications such as automotive or Milero. And the Siva New Pro M seems more like a generalist, but it does feel like it can also take on heavier workloads with its sparsity and compression engines and quantization kind of built right in. Now, that being said, Siva has had a long history of delivering IP, while Quadric and Expedera are a little bit newer in the space. So as far as some of the integration and customer support help, and software, I would expect Siva to have a stronger foothold in this space. So as we start to turn the page on this series, I want to kind of go over some of my final conclusions as I've delved into Quadric's Chimera line, as well as kind of pondered in my spare cycles. The Quadric Chimera claims to be future-proof, and I do believe that. I think with the mix of CPU and DSP capabilities that are intrinsic to the architecture, this allows a level of programmability that will start to allow users to go from transformers to large language models and to whatever is next. So there is a lot of programmability which can help with the future proofing. Now, the downside of that is if you aren't building something super specialized, like let's say Thales is doing for transformers, you may be leaving some performance on the table. Is it better than a CPU or a DSP by itself? Probably, because they figured out how to unify the architectural pipelines. Its deterministic nature is well suited for high reliability applications such as automotive and military and aerospace applications, but those also require the most amount of proof. There's a lot of steps to get into a military and aerospace program, and automotive definitely requires some degree of silicon proof, and realistically, they don't want to be the first ones to do it. So this is kind of a chicken and egg situation. And finally, as we cover as we close this out, I do still have questions on the data movement. They may be truly scalable within one core, whether it's the QC Nano all the way up to the individual instance of the QC Multi. But between those multi-cores, I'm not certain that there's that scalability in that data fabric. And on top of that, Qualcomm has kind of shown this, where even though you may have an architecture that works on the edge, it doesn't necessarily scale all the way to the data center, because you need to create a discrete solution for each of these steps because there are electrical issues that come with it. There are power issues that come with it. There are data fabric issues that come with it. So claiming to have true scalability does add a little bit of doubt into this product. That being said, this is quite an interesting architecture, and I'm excited for the future of Quadric, but I do think that they need to show more points of silicon proof out of NDA and kind of in the wild, because this will allow some of those high reliability application players to take more of a chance. Now, that being said, nobody puts IP directly into the next car and shoot it off to the factory. There's going to be a bunch of test chips and test devices and test vehicles before it actually sees production. But even getting that first meeting, it would be interesting to see more customer and silicon proof examples out in the wild. That being said, thank you very much for listening to me yammer on about the Quadric Chimera. It's been a pleasure. And if you like these videos, please like, subscribe, and drop a comment. I think for my next piece, I'll probably be covering the Expedera origin. If you have any suggestions or any comments, please let me know. Thank you. Bye.